Hello, and welcome to our channel. In this video, we'll show you how to set up cloning between two recording servers with the help of Surveillance HA and its plugin for Milestone XProtect. Surveillance HA is Tiger Technologies' seamless and zero-loss failover solution. It can be installed separately or together with our Surveillance Bridge product. For more information on the installation and use cases of Surveillance Bridge, please check out the respective videos we've posted. If we check the Recording Servers section of the Management Client, we can see the two servers we would like to clone. One of them has a number of cameras attached. The other one is currently empty and has no devices connected to it. To enable server cloning, go to the High Availability tab of Surveillance HA. Select your primary server, the one with the cameras attached, and click on Server Cloning. Doing this will initiate the Server Cloning Wizard, which will guide you through the setup. As a first step, type in a name for the HA server pair. You need to select a secondary recording server, which you will pair with the primary one. This section will only list recording servers that do not have any devices currently attached to them. On the next step, you can select a shared IP address or shared DNS name configuration for your HA pair. Using shared IP or DNS will reduce the downtime experienced during a failover event. In our case, we would go with a free IP address to be shared among the cluster nodes. The wizard will check for a matching volume between the two servers and present a green check if it finds what it needs. Otherwise, you'll see a red cross. You have the option to skip volume validation, although this is not recommended. On the last step, you can select whether you want to restart the recording servers automatically at the end of the HA configuration process. If you do not, you can restart them manually later, but your configuration will not be fully applied until they are restarted. Once the server cloning process is complete, you can exit the wizard and go back to the Surveillance HA plugin. Initially, both recording servers will show a standby HA status, and only one of them will show a green status for its cameras underneath. After a while, when the devices get initialized on the secondary server, you will see the green status for all the cameras on the other node as well. In a few moments, one of the nodes will take up the serving role, while the other will remain on standby. In the right-hand side, you can see statistical information about the recordings that are currently managed by the corresponding server node. Displaying camera data for the secondary node may take up to an hour, as there will be insufficient data available for calculation and analysis immediately after the server cloning process has completed. You can use the Switch option to transfer the serving role between the HA nodes manually when necessary. As you can see in the UI, the serving node is always highlighted, while the standby node is a bit less opaque. If you transfer the serving role to the other node, it will become highlighted, while the formerly serving node will assume the standby role and will become less opaque. Additionally, on the right-hand side, you can choose the behavior of the automatic backfill functionality for each recording server. This feature makes it possible for one recording server to backfill missing recordings, as long as its counterpart has it. This is especially useful for planned maintenance procedures and in case of unexpected temporary failures. It's important for the user to understand that automatic backfill is a feature that works proactively. When this feature is enabled, Surveillance HA will generate a string of placeholder data that would perfectly fill up the missing recordings from the time of the last stoppage of the recording server up to the point when it was turned on. Then the software will collect the missing data from the counterpart recording server and replace the placeholder recordings with actual video footage. This feature will not backfill missing data from older downtime periods. Selecting placeholder data will only create temporary placeholder frames in the position of the missing data. Having placeholder data enabled allows the user to backfill the actual data only when necessary. To do so, they only need to switch from placeholder data to enabled. If you select disabled, Surveillance HA will not attempt to create any placeholder frames and backfilling data will no longer be possible. There are a few additional settings available to the user for fine-tuning of their server cloning configuration. The first one, Infrastructure Force option, which is enabled by default, would try to automatically load all missing components for normal operation. For example, if the XProtect recording server service is stopped while Infrastructure Force is enabled, Surveillance HA will try to start the service automatically in a few moments. The second option, Primary Force, which is disabled by default, would always force the serving role on the primary node as long as it is currently operational. The third option, Network Tolerance, will determine the length of the delay before a failover occurs. Larger tolerance means that the system will wait a few more seconds before the serving role is transferred. This option is set to normal by default. Lastly, you have the option to disable the HA pair if it is no longer required. Disabling the server cloning configuration will break the connection between the two recording servers. Additionally, the secondary node will assume its former ID, the one that was discarded during the server cloning process, thus returning to a blank slate with no devices attached to it. This concludes our video showing you how to set up server cloning with Surveillance HA. Thank you for viewing.